we drew graphs, and I said that you could sometimes draw the resultant without having to actually graph it. And today you'll kind of see that, why it happens, because you'll see it algebraically. Some of you that already know about vectors, took physics, you might already know all that, but if not, this is another way to think about vectors algebraically. First of all, there's two ways to write it. You can write it in component form or component form in terms of I and j. So when you have component form of a vector, you're thinking about the horizontal and vertical change. Yesterday we counted the little boxes left or right, which is horizontal. We counted the little boxes up and down, which is vertical. So that's how we're going to write vectors today as well. So this vector, remember that's bolded, so if I was to rewrite this, I could write this as this vector is equal to, the horizontal change is going to be considered the a value, or if you're thinking about a coordinate plane, the x value, and then the vertical change is the b value. The reason we use a and b is because you'll see the next one, terms of I and j, uses the letters a and b. But again, a is the horizontal is the x value, b is the vertical is up and down, which is the y value. So when you're writing a component form in terms of I and j, you're using the same information, horizontal and vertical change, but you're putting it in front of the I and in front of the j. A and b are values. Kind of like if you were writing an equation of a line, y equals mx plus b. The m and the b have values. Same thing here. The a and the b have values. The I and the j are part of the problem. So if you were writing this, remember this v, this I, this j are bolded because it's typed. If you were writing it, it would be vector v equals whatever the value of a is. Your I would have to have the arrow or half arrow over it, and so would the j. The little vector symbol does not go over the number. Remember, a and b are values. So I'm just rewriting it that way so that you can see the difference between typed versus what you have to do, which is written, because I will not accept you writing in bold. And then yesterday we talked about the magnitude of a vector is its length. So now we're going to figure out how to actually find that length. And all it is this formula right here. So if you're given a vector and you know the horizontal and vertical change either in component form or terms of I and j, remember those symbol right there, then the magnitude of vector v, that's what that symbol is right there, the two little lines on each side, is equal to the square root of a squared plus b squared. So the square root of the horizontal change plus the vertical change. So those things you need to know. Component of a vector, component form, terms of I and j, and then how to find the magnitude. So how to find the horizontal and vertical components. There's a couple different ways to do this. These are some formulas that you can use. If you use these formulas, then it's very important that you know what that theta means. And the theta is defined right here as direction of a vector. So the direction, which is going to be theta in this unit, is the smallest positive angle. Okay, smallest doesn't mean it has to be acute. It could be acute if it's in quadrant 1, but if it's in quadrant 2, it's still the smallest positive angle. If we're in quadrant 3, somewhere between 180 and 270, it's still the smallest positive angle formed by the x-axis and the actual vector. If we're in quadrant 4, then it's going to be somewhere between 270 and 360. So don't get confused with that word smallest. Smallest just means, we could really just say direction is the positive angle in standard position form. But the reason we say smallest is because you don't know where the vector is going to be. So if you're going to use these formulas to find A, which is the horizontal, and B, which is the vertical component, we take the magnitude, multiply that by the cosine of theta, which is the direction. Now, you can also use right triangle trig. You'll see in a minute when we draw the vectors, you can make a right triangle and use your SOHCAHTOA. That is fine as well. It does not matter to me whether you use these formulas or you use your SOHCAHTOA. So the unit circle does come up a little bit, still has not gone away. If the value given is on the unit circle, then it would be a non-calculator problem. So if the problem includes a 30 degree, 60 degree, 45 degree, 135, 210, 300, any of those, it would be a non-calculator problem. If the angle given was 20 degrees, we can still use right triangle trig or this formula. You just need a calculator for that. So this definition right here, direction of vector, is going to be very important because a lot of times it's going to ask for the direction. So if it asks for the direction of that vector right there, the direction is the smallest positive angle in standard position. Standard position starts at the x-axis and goes all the way to the vector. So that would be your theta. This right here would be your alpha, which is your reference angle, so you could use that to help find what your direction is. But no matter what quadrant you're in, standard position all the way to that angle is direction. And that's what you need to use when you're using these formulas. If you use that when using those formulas, you'll get the correct sign. If you use the reference angle in those formulas, you'll get the correct value, but you won't always necessarily get the correct sign. Because if you're in quadrant 2, the A value is going to be negative. Quadrant 3, A and B are going to be negative. Quadrant 4, B is going to be negative. And all that has to do with X and Y. What are the X and Y values in each of the 4 quadrants? The operations, these should be pretty easy and self-explanatory when you look at it. All it is if you have 2 vectors, you're adding or subtracting them. You just add or subtract the horizontal components together, add or subtract the vertical components together, and then you have your new component form. And then the scalar, the k, that's just distributing. So you can just distribute into component form. And you can do the same thing with these, whether it's in terms of I and j. If it's in terms of I and j, you just combine the i's, combine the j's, or distribute the k to the a term with the I and the b term with the j. So operations should be pretty simple, but very easy to make a silly mistake. So if you tend to make careless errors, just be sure you show all your work for problems like that. All right, so these problems are asking you to do 3 things. Write in component form, terms of I and j, and find the magnitude. So once we do letter A, we have all the information that we need. We just have to know what the directions are asking for in B and C. Because no matter what, we have to find the horizontal and vertical component, or in this case, we don't really have to find it. We just have to locate it on the problem that's given. So for letter A, write each vector in component form. So we have to start at the initial point. Okay, the initial point is not the point where the arrow is. The initial point is the dot. So we're going in the direction of the arrow. So if we start here, our horizontal component is left or right. So since we're going to the right, that's positive 2. Then we go down towards the arrow, so down, that's why that's negative 3, that's the vertical component, and there's your vector in component form. You start at the dot. If you go left, it's negative. If you go right, it's positive. Then from there, if you go up, it's positive, down is negative. So component form can both be negative, both be positive, or one of each. And then letter B just says write in terms of I and j. Here's the A value, here's the B value, so we have 2i, and then just minus, we can say plus a negative. I don't like those double signs, so we're just going to say 3j. And don't forget your arrow or half arrow over the I and the j. It does not go over the 2 or the negative 3, it only goes over the I and the j, because it is a vector. And then the magnitude is the square root of a squared plus b squared. I do not have to see work for that. If you can do the square root of a squared plus b squared in your head and write down the answer, that is fine with me. I do not have to see this work. But if you need to show the work, 2 squared is 4, negative 3 squared is 9, so we get our answer to be the square root of 13. So that's component form, terms of I and j, and finding the magnitude. And then number 2 is the same. So these dots, just because these dots go down and then over doesn't mean we switch the horizontal and vertical component. The horizontal component comes first, the vertical component comes second. So I'm going to start at the dot, and even though the 4 is right here, this is still negative 4 up here also because we went to the left. So our horizontal component is negative 4, and then we went down, so -1. Then when you write in terms of I and j, -4i, and then I would just do minus j. If you do -1j, that's fine. Just know that if it's given to you in terms of I and j, typically there's not going to be a 1 right there. You have to know that that would be the b value. It would be -1. But if you write -1j, again, that's fine. Just make sure your vector symbol does not go over the 1, only over the j. And then again, letter C, if you can do that in your head, terrific. You need to show a little bit of work. -4 squared is 16, plus -1 squared is 1. So we get the square root of 17. And on your quiz Friday, you're going to be able to use the calculator the whole time. So on this problem, it's best to leave it as a square root of 17, but if you put the square root of 17 in your calculator and press enter and round it to the thousandth, that's fine. Just be sure you don't round incorrectly, because you might have the square root of 17 written on your paper, and then if you don't round to the thousandth or you round incorrectly, you could end up getting it wrong. Okay, so just be careful when you are plugging things into the calculator that you don't have the right answer and then all of a sudden you have the wrong answer because either you rounded wrong, you typed something in incorrectly. But I would take the square root of 17 or whatever the square root of 17 equals if you had the use of a calculator. All right, number 3, same type of problem, but it just doesn't give you. All you have to do on number 3 is actually count, kind of like we did yesterday when we were counting. So A would be the horizontal component. We always start at the initial point. Okay, the initial point is the dot. The terminal point is the arrow. So we started at A, and we went to the right. 1, 2, 3, 4, 5, 6, 7. Since we went to the right, that's positive. And then up, 1, 2, 3. Up is positive, so we get 7, 3. And then in terms of I and j, 7i with the symbol plus 3j. Don't forget your symbol. There are lots of little bitty picky things that you can get a lot of points wrong on this, so be careful and make sure you're doing all those little things correct, because it can add up quickly. And then letter C, the square root of 7 squared, which is 49, 3 squared, which is 9. So we get the square root of 58. If you get a square root, let's say we got the square root of 60, then we need to be able to simplify that. So if you get something that can be simplified, just be sure you simplify that, especially if it's not with a calculator. If it's with the calculator, you still need to be able to simplify it, whether it's using the calculator to simplify it or changing it to a decimal. And then this last one, I'm not going to work it all out, but all this is the proof of why this, really what we're finding is the distance. The distance formula. Okay? If we find the horizontal component, this goes back to yesterday. We talked about displacement, the end value, terminal point minus the initial point. Talked about that yesterday on that very first sheet, those definitions you wrote down. So x2 minus x1 plus y2 minus y1, and then we take the square root of that. Well, when you take the square root of that, that gives you the distance. Magnitude is what we're looking for, which is the distance. Okay, we're not doing proofs, we're not going back to having to prove things, but that's what that problem is. It's just the proof of really what you're doing is the distance formula. All right, so this one gives it to you just in words. Instead of giving you a picture, it gives it to you in words. And you can do this a couple different ways. Yesterday we did graphic, today we did algebraic. It is up to you, whatever's easier for you. If you need to draw a picture on a little piece on graph paper, or just draw a little picture off to the side, then do that. If you like algebraically, terminal point minus initial point, you can come up with your change that way. That's okay too. So we want component form and the magnitude. So we have two different answers. So the first thing is component form. If drawing a picture is helpful to you, then do that. So if we have this picture right here, and we know initial and terminal, again because of yesterday when it's written in this form, the first letter is the initial point, the second letter is the terminal point, just from our notes yesterday. So we have the point A over here, and B. So if A is the initial point and B is the terminal point right here. Graphically, you could count. Algebraically, you can just subtract. So yesterday, graphically, we just counted. How did we get here? Well, we counted, we went 1, 2, 3, so we went over 4 and down 1. Since we went to the left, that's negative. Since we went down, that's negative. Or, knowing the displacement is end, terminal point, 0, minus 4 is negative 4. 1 minus 2 is negative 1. Up to you how you determine that. So component form would be negative 4, negative 1. There is component form. Then find the magnitude. Remember those two little lines on the outside of the vector means magnitude. So the magnitude is going to be the square root of a squared, which is 16, plus b squared, which is 1. So our magnitude is the square root of 17. And eventually we're going to use this stuff to actually do application, real life problems. But you need to know how to find all of these things first. And here are the operations. Now, the operations, I do not have to see work for this. If you want to show work, if you tend to make careless mistakes, I would say show your work, but you do not have to show work. I'm going to show it just so you can see what I'm doing in case you like to show each and every step. But all of these problems, pretty much all of them, you could probably just look at it and figure out the answer. So v plus w. So we go up to here, and vector v is negative 4, 6. Vector w is negative 5, negative 3. So that's what we're doing. We're doing that operation. Again, if you can do that in your head without writing it down, that is fine. So, negative 4 plus negative 5. So that results negative 9. 6 plus negative 3. That result is 3. So there is your answer. Yesterday, we would have graphed each of those vectors and then graphed the resultant. So if you think about yesterday's assignment and you go back and count whatever the first vector was and add or subtract it to the second vector, you'll see that the resultant vector, your dashed line, should match up. Okay, so this is just the algebraic way of what we did yesterday, adding two vectors. Now letter B, we already did v plus w, we just did that. So we don't have to do it again, but we have to multiply it by 2. So it's just negative 9, 3. So we just distribute that 2 in there, and we get our answer to be negative 18, 6. Very important that you have those angle brackets. Chevrons, angle brackets, I like calling them angle brackets, but they can be called either one. That is what makes it a vector. All right, and then letter C, we've really kind of done letter C too, because we could have made this, we could have distributed that 2 and made that 2v plus 2w. That's the same thing. Whether we find the v plus w and then distribute the 2, or distribute the 2 and then add them. We can do that either way. So really, we already know what 2v plus 2w is. It is negative 18, 6. So we're finding the magnitude of negative 18, 6. So the square root of negative 18 squared plus 6 squared. So we get the square root of 324 plus 36. So that's the square root of 360. 360 is a pretty easy one to simplify because of 36. The way I do that is I think of that as 36 times 10. 36 is a perfect square, so 6 root 10 would be your magnitude. So again, those two little double bars on the side of a vector means find the magnitude, the square root of a squared plus b squared. A is the horizontal change and b is the vertical change. And then here we have u, which is 5, 2, plus 1/2 of v, which is negative 4, 6. Once again, if you tend to make careless errors, don't try to do it in your head and try to get through it quickly and make a simple error that can cost you 2, 3, 4, 5 points. Write it down so you don't make an error. So we have plus, negative 2, 3. We distribute that 1/2 in right there. We can't add these two and then multiply by 1/2. That's not following order of operations. Still order of operations, PEMDAS. We have to multiply before we add and subtract. So then we have 5 plus negative 2, which is 3. 2 plus 3, which is 5. And there is your answer. So that's the operations when it's in component form. You can also do the exact same operations when it's in terms of I and J. All it is distributing and combining like terms when you have I and J. So we have 2 times 3I plus 2j. And if you can do that without writing it down, just write down what it is, that's fine. And then we have plus 5 times negative I plus 6j. So we distribute 6I plus 2j. Distribute the 5, that ends up with negative 5I. Distribute the 5 plus 30j. Or if you want to keep the plus sign with parentheses and make it a negative 5, that's fine too. Plus and negative is the same as minus. And now again, we just add like terms. 6I minus 5I is just I. Or if you like 1I, you want to put the 1 there, that's fine. Oh, that should be 4. 2 times 2 is 4. When I distribute that 2. So plus 34j. So there are the operations when it is in terms of I and j. So you have component form of a vector. That's the angle brackets with the a comma b. You have in terms of I and j. You still have to find a and b. The a goes in front of the I. The b goes in front of the j. Just don't forget the vector symbols. Either the arrows or the half arrows, whichever you prefer. All right, so here a vector has length 8 and direction 30 degrees. So when it tells you the length and the direction, you have all the information you need to use those formulas that we used earlier. If you draw it and you realize you want to use right triangle trig or SOHCAHTOA, you are more than welcome to do that. You do not have to use these formulas. If you do use these formulas, you just have to remember that theta is the direction. And if you use the reference angle instead of the direction, the signs might not necessarily be correct. Now in quadrant 1, the reference angle and the direction are the same. But in quadrants 2, 3, and 4, that's where it changes. So if you want to use the reference angle but then adjust your signs accordingly, then you can do that. So just remember, if you're in quadrant 1, everything's positive. Quadrant 2, A, or the horizontal is negative. Quadrant 3, they're both negative. And quadrant 4, the down, the y value is negative, or the b value. So we want to find the horizontal and vertical components. So I'm going to use these formulas. So the horizontal component is A equals the magnitude times the cosine of the direction. B equals the magnitude times the sine of the direction. Now, is this more to memorize? Kinda. But let's think back to unit 1 when we talked about cosine is what variable? The x. Sine is the y. A is the x value. B is the vertical, which is the y value. So that's why A goes with cosine and B goes with sine. Because cosine is the x and sine is the y. So we have A equals 8. Cosine of 30, that unit circle still hasn't gone away. So if you need that unit circle out just to reference to make things quicker, go ahead and do that. Some of you might not need that. So root 3 over 2. So our horizontal component is 4 root 3. There's one answer. Vertical is 8 times sine of 30. Sine of 30 is 1/2, so our vertical component is just 4. Again, following the directions. It says find the horizontal component and the vertical component, not put it in component form. It does say write the vector in terms of I and j. So our vector in terms of I and j is A, which is 4 root 3 I, plus 4j. And if you didn't write the vector equals, that would be fine. Okay, just the terms of I and j would be okay in this problem also. You would not have to say vector v equals unless you want to. If you like SOHCAHTOA, okay, and you decided to draw a picture on this one. So if I were to draw this picture, here's a 30-degree angle, and my vector has magnitude of 8. This is just a different way to work it, if this makes more sense to you. And we drew this right triangle right here. This right here is our horizontal component, which is A. This is our vertical component, which is B. So now we could say cosine of 30 degrees equals A over 8. Sine of 30 degrees equals A over 8. And then what happens when you solve for A? You multiply by 8 on both sides. 8 times the cosine of 30. Okay? So SOHCAHTOA works exactly the same. If that angle, the direction had been 31 degrees, all that would change is we'd need a calculator. Or if it had been 20 degrees, only thing that changes is we have a calculator. If it's anything that's on our unit circle, we can do it without. All right, here, find the magnitude and direction. Again, important to remember what the direction is. This is our definition from earlier. The direction is the smallest positive angle, not necessarily acute. Okay, it's from standard position, which is the x-axis, all the way to the vector. So quadrant 1, it's going to be between 0 and 90, 2 between 90 and 180, and so forth. Okay, we're going to assume the tail of the vector is at the origin. If you can do this without a picture, that's fine. I'm going to draw a little picture. So it says assume the tail is at the origin. So we've got to figure out where is it. Does it come out quadrant 1, 2, 3, or 4? Well, that's what this is going to do. This is our A value. Our B value, right there, is 1. A is our horizontal change. So our horizontal change goes negative, which is to the left. So that's negative root 3. Our vertical change goes up, which is 1. So therefore, there's our vector right there. Some of you who know your right triangles really well, you can figure out what that magnitude, which is the length, is very easily. You can see that triangle. You know your ratios of special right triangles. If you don't recognize that that's 2, then what do? You have a right triangle. Negative 3 squared plus 1 squared equals c squared. 3 plus 1 equals c squared. 4 equals c squared. So c is equal to 2. So again, if you don't recognize it, if it's not a triple, you always can fall back to your Pythagorean theorem when you have a right triangle. So we found the magnitude. The magnitude is 2. And now we have to find the direction. The direction is standard position to the vector. So that's our direction right there. Now, some of you can look at that and you know what it is right away because you know your triangle, the 1, 2, and negative root 3. So you know this alpha, this theta right here is 30 degrees. So if that's 30 degrees, then what's left is 150 degrees. If not, then you just have to use your SOHCAHTOA, whatever you want to use. I like the 1/2 right there. So I'm going to say the sine of alpha is equal to opposite over hypotenuse. So the inverse sine of 1/2 is equal to what angle? Again, we're back to our unit circle. That's going to be 30 degrees. So we found our reference angle of 30, but it asks for direction. Directions from the positive x-axis to the vector. Okay, direction is always positive. Always, always, always positive. Be sure you know that definition of direction because it will come up a lot. All right, and that's it. So this is just a correction that you need to make